Hey guys, in this tutorial, this is what we are going to be making, this really weird sort of munted, woven piece of mangled geometry. Alright, let's take a look at how to do it. We're going to start with a simple curve that we make in Rhino, using the control point curve, just click several times to make it, and I've already made one, so now we're going to reference that into Grasshopper. Using a curve parameter, I'm going to set one curve, and then I'm going to pipe that curve. So we'll plug the curve into the curve parameter, and we also need a radius value. So I'm just going to make another slider. I'm just going to make a slider for that. I'm going to give it a max value of maybe 50, and then we'll plug it into my radius, and you know what, I like it about there, somewhere around 30 is good for me. Alright, now we're going to divide that surface. 10 and 10 divisions will probably be alright for me, but I'll lay down a slider on it anyway. Give it a max value of 20. And, oh, okay, that'll be 9 instead of 10. And that one will be 10. Alright, at this point we are going to use cull pattern. Cull pattern is a really useful node. I'll show you what it does right now. I'm just going to lay down a simple rectangle, and I'm going to turn it into a planar surface, and then I'll just copy my divide for now. And so when I plug, okay, here's what my surface division looks like at the moment. Very regular looking. As soon as I plug it into my cull pattern, you should notice a difference. What it basically does is takes a true and false pattern and gets rid of and keeps geometry based on that. And we can set our own custom pattern using just a panel. So I'm going to set my pattern to true false and plug it in. And you'll notice that the cull pattern is going to throw an error because it can't convert from a text parameter to a boolean. A boolean is basically just a true or false value. So we're just going to right click on the panel and set the panel to multi-line data. As soon as we do that, Grasshopper is, the cull pattern is happy with what we now want to do. Alright, so we have this. We have now gotten rid of every other piece of, or every other point, so we only have every second point. We could, however, do whatever we want with this pattern. So if I wanted to keep 2 out of every 3, or 1 out of every 3, I'm free to do whatever I want. But I'm happy keeping every other item. And just to show you what we're going to do next, we're going to take this colored list of points, and we're going to flip the matrix so that we can put it through another cull pattern, and once again get every other point. So now we're just going to plug our original surface division into that, and there we go. Now I also need to get the normal vector at each and every one of these points. So I'm going to make a copy of these 3 nodes, copy my normal vector, and now I'm going to put down a vector amplitude node. Vector amplitude node basically allows me to manipulate a vector to any length that I want, and I can do that using a slider. So I'll double click my slider, edit it, maybe I'll give it a maximum value of 10, and then I'll plug it into the amplitude. And now I'm going to move each of these original points that I created based on this vector. And you can see as I increase my amplitude, the points update accordingly, and I'm going to preview these off. Now I'm going to make a copy of this because we have every other point, we have every second point, but we still want the points in between. So we're going to make a copy of all of these nodes, and basically we just need to reverse this pattern. Now we could just grab another panel and type in false true instead of true false, but I'd prefer to keep this whole thing parametric so that if we did want to change this pattern at some point, we don't need to update two different panels. And the way we can do that is using what's called a NOT gate. A NOT gate is a simple logic operation which flips true and false values. So a false will now equal a true, and a true will equal a false. And so we'll plug this into our cull pattern, and just to check, maybe, no, wait, I don't quite want it in those two. I'll just undo that. I want and plug it into these two. Okay, and I'm also going to turn this vector negative, and I'll plug it in. So now we should be getting one point in the positive direction and 1 point in the negative direction. And now we need to combine these two data streams back together so that they form one line, so that they can form one line. And the way we do that is using a weave component. So the weave component asks for a weave pattern, so we're going to plug in, and it's 0, 1, which is fine. We want the pattern to alternate, and so when we plug that in, we should now have our pattern woven properly, and we can use an interpolate curve. And so here we go. We now have part of the woven geometry. And now we need to create the next half. And this is literally just as simple as copying. Actually, I'll copy all of this, including the panel. And then wherever we have these true and false patterns plugging in, we need to switch them with the NOT, with the opposite of that. So let me see, I'll just drag this over here. Oh, maybe the computer's lagging a little bit. Oh, it's really taking its time. Okay, so this goes into here, and here, and here, and here. And so we now have the rest of our pattern, but you can see that it's going in, if it's going to be woven, these intermediary lines need to be in the opposite direction. So all we do here is we flip where this negative parameter goes, and there you should be able to see that that is now working. I'm just going to flatten these outputs, and I'm going to weave them back together. So that once I have done this, we can now pipe the geometry. Alright, now we need to create all of this in the opposite direction. And the way we do that is by copying all of this, apart from the not gate. Make a copy of that. And what I'm going to do is I'm going to flip this matrix coming into here. I'm also going to flip the normal matrix, and I'm going to plug these back into each other, and we'll see, we might have a slight mismatch, but nothing that isn't easily correctable. I'll just drop down a pipe down here as well, and we'll see what we get. So we're almost there. We just need to switch our negative and positive normal results. So what I'm going to do is I'm just going to lock this over so I can do this really quickly, and we'll reconnect these up. And now when we turn this on, it should all be working. There we go. Oh, I'm going to get rid of my curve. And so that's basically it. Really simple definition. All we had to do was create the first part of it, and then it was basically just copying and pasting that. And now we can change this amplitude to whatever we want. We could also drop down an amplitude for these pipes. In fact, I might just plug both of these pipes into the same components because we don't need two of them doing the same thing. And I'll plug a slider in for my radius. And I might just set that to 2. And there we go. There's our woven pipe basically. And now you should be able to basically apply this to any sort of surface you want. If I were to just bring that curve back, okay, what I'm going to do really quickly is I'm going to combine my outputs so that we only have one for each. All of these everything coming out of this NOT gate is going to go into this NOT gate. Same with this NOT gate. I might just lock my solver, see if that makes things run a bit smoother. Same with this Boolean pattern. Just sort of missed it there. And same with my points and normals. Let's check to see if it's still working. Cool. So if I now were to plug this surface into here, there we go. You can see it still functions absolutely perfectly. But we'll just plug it in back to where it was. Get rid of my curve and my rectangle. And we're going to bake this out to see how it looks. There we go. That's how to make a weaving pattern.